The star Betelgeuse, a red, very massive monster found in the superb body of Orion, has long charmed stargazers and cosmologists alike because of its sheer size and brightness. In the event that Betelgeuse were placed where our Sun is, it would extend out to the orbit of Jupiter, affirming its colossal size. Despite being located around 642 light-years from Earth, its gigantic size makes it quite possibly one of the most brilliant stars visible to the naked eye. Recently, Betelgeuse has shown bizarre behavior, such as amazing darkening and lighting up cycles, which many researchers believe signal that the star is approaching the end of its life. The famous physicist Brian Cox recently made a critical statement that Betelgeuse is on the edge of a devastating blast expected to occur within the next 2 weeks. This event, known as a supernova, will mark the end of Betelgeuse's life, but will provide a phenomenal opportunity for researchers to study one of the most surprising and powerful phenomena in the universe. As a red supergiant, Betelgeuse is classified as one of the largest and most massive types of stars. It has been on the astronomical radar for many years, but its new eccentric fluctuations in brightness have sparked theories that it is preparing for a supernova. When a star like Betelgeuse reaches the end of its life, its core implodes under its own gravity, leading to a massive explosion that releases an enormous amount of energy, radiation, and cosmic material into space. Betelgeuse's approaching blast is anticipated to be a Type II supernova, a specific type of celestial explosion that happens when the core of a massive star collapses. This core collapse triggers the release of neutrinos and radiation, creating a shock wave that tears the star apart. The explosion will be so bright that it may be visible from Earth without telescopes, possibly even outshining the moon in the night sky for weeks or months. While such an event would normally be catastrophic if it happened near Earth, Betelgeuse's distance of around 642 light-years means that although the blast will be visible and dramatic, it will not pose any danger to life on our planet. Nevertheless, the event promises to reshape our understanding of supernovae and cosmic phenomena. A supernova is one of the most powerful events in the universe, releasing more energy in a few seconds than the Sun will release throughout its entire lifetime. Betelgeuse's blast will not just be an astonishing cosmic display, but also a significant moment for science. Researchers are eager to observe this intriguing event from its earliest moments using a variety of ground-based and space-based telescopes, including the Hubble Space Telescope and the James Webb Space Telescope, JWST, to capture as much data as possible. When Betelgeuse explodes, it will emit a wide range of radiation from visible light to gamma rays. One of the most crucial aspects of the supernova will be the flood of neutrinos, elusive subatomic particles that rarely interact with matter. Neutrinos from a supernova can actually reach Earth before the light from the blast due to their ability to pass through almost everything without being affected. Observatories like Japan's Super Kamiokande and the Ice Cube Neutrino Observatory in Antarctica are preparing to detect these neutrinos, providing an early advantage in monitoring Betelgeuse's final moments. The explosion will also provide vital insights into the creation of heavy elements. When stars detonate, they produce and scatter elements like iron, gold, silver, and uranium, materials essential for life as we know it. Studying Betelgeuse's supernova will offer researchers a clearer view of this element formation process, which is crucial for understanding the formation of planets and the chemistry of the universe. While Betelgeuse's supernova is not expected to have a destructive impact on Earth, it will interact with our planet's atmosphere and magnetic field in captivating ways. The energy burst from the explosion, specifically the emission of cosmic rays and charged particles, could result in more intense auroras, expanding the regions where the northern and southern lights are visible. While these cosmic rays could affect satellite communications and some technologies on Earth, the disruptions are expected to be minor and brief. Perhaps one of the most exciting parts of Betelgeuse's blast is that it will be visible to everyone on Earth, not just professional astronomers with advanced equipment. For weeks or even months, Betelgeuse is expected to be the brightest object in the night sky, potentially even visible during the daytime. This spectacle will captivate not only the scientific community but also amateur astronomers and the general public, sparking renewed interest in space science and the universe. Scientists have long speculated about Betelgeuse's death, but Brian Cox's recent statement adds a sense of urgency. Observatories worldwide are preparing to monitor every phase of the supernova, and the data collected will be critical, potentially changing our understanding of stellar evolution, supernovae, and the distribution of heavy matter in the universe. Betelgeuse's supernova will allow researchers to refine their models of cosmic distances. Being relatively close to Earth, it offers a unique opportunity to measure how energy from such a blast travels through space. By observing the light and radiation from the supernova as it interacts with the interstellar medium, the gas and dust between stars, astronomers will gain a clearer understanding of the size of the universe. The event will also offer a once-in-a-lifetime opportunity to investigate dark matter and how it might influence the structure of the universe. Dark matter, the mysterious substance that makes up about 85% of the universe's mass, does not emit or absorb light, making it difficult to detect. However, observing how light and matter behave around Betelgeuse after its explosion could provide indirect clues about the role dark matter plays in the universe's large-scale structure. Betelgeuse's supernova will also bring us closer to understanding the life cycles of stars, particularly how massive stars contribute to the formation of the elements essential for life. Supernovae are the key cosmic events responsible for spreading heavy elements throughout the universe, elements that ultimately form new stars, planets, and even living things. By studying Betelgeuse, scientists will gain valuable insights into how these elements are created and distributed. The social significance of Betelgeuse's explosion is also important. For centuries, humans have looked to the stars for guidance, inspiration, and meaning. The disappearance of one of the most visible stars in the Orion constellation will provoke philosophical reflection on the transient nature of the universe. In some cultures, such divine events have been interpreted as omens or signs of monumental change. Betelgeuse's blast may inspire a mix of awe, fear, and wonder as people from all walks of life witness the death of a star. This grand event is likely to reignite interest in space exploration and stargazing, drawing more people into the search for knowledge about the universe. Amateur astronomers are already preparing for the event, as modern technology allows nearly anyone with a camera or telescope to observe and record the supernova. This democratization of science will unite people across the globe, all watching and recording the same massive phenomenon from their unique vantage points. Betelgeuse's explosion isn't just a spectacular cosmic event, but also a stepping stone for future exploration. The data gathered from the supernova will inform how we study other stars, particularly as we venture further into space with missions to other planets and stars. Understanding the life cycles of stars and the properties of supernovae is crucial as humanity looks to extend its presence in the solar system and beyond. Additionally, the explosion will reignite interest in the search for extraterrestrial life. Supernovae are essential for spreading the components needed for life, like carbon and oxygen, across the universe. By studying Betelgeuse's explosion, scientists can better understand how the building blocks of life could spread to other planetary systems and possibly spark life elsewhere in the universe. The impending explosion of Betelgeuse is set to be one of the most significant cosmic events in recent memory. Its supernova will provide a wealth of scientific data, enhance our understanding of the universe, and undoubtedly captivate people around the world. Betelgeuse's death will mark the end of a giant star, but it will also represent the ongoing cycle of creation and destruction that governs the universe, reminding us that from death, new stars, planets, and even life itself can emerge. As we prepare for this historic event, the world will eagerly watch the night sky, anticipating the moment when one of the universe's most powerful forces detonates into view. For both researchers and stargazers alike, Betelgeuse's final journey will be awe-inspiring. As Betelgeuse approaches the last stage of its life, one of the more speculative but fascinating possibilities related to its impending explosion is its potential to shed light on some of the universe's greatest mysteries: dark matter and dark energy. These puzzling forces are believed to account for the majority of the universe's mass and energy, yet they remain poorly understood. Some speculate that supernovae, like the one expected from Betelgeuse, could hold the key to unlocking some of these mysteries. Supernovae release vast amounts of energy and radiation, and some researchers believe these powerful forces may interact with dark matter in ways we can observe and study. One intriguing hypothesis is that dark matter exists in the form of weakly interacting massive particles, WIMPs. If WIMPs exist, Their interaction with the energy generated by Betelgeuse's supernova could provide clues to their nature. Such a discovery would be historic, offering the first direct evidence of dark matter, an elusive phenomenon that has puzzled scientists for years. Moreover, there is potential for Betelgeuse's blast to offer insights into the nature of dark energy. Dark energy is the mysterious force driving the accelerated expansion of the universe. Understanding its role in cosmic evolution is one of the most significant challenges in modern physics. Betelgeuse's explosion could provide indirect evidence of dark energy's influence on stellar death, as supernovae are thought to be affected by the universe's expansion. Observing how Betelgeuse's supernova propagates through space could provide key data to help scientists understand how dark energy affects cosmic events and influences the universe's large-scale structure. As Betelgeuse's supernova draws closer, the scientific community is preparing for one of the most anticipated astronomical events of the century. The explosion will offer a unique opportunity to observe the final stages of a massive star, providing insights that may have implications far beyond our current understanding of stellar life cycles. While researchers anticipate the supernova's dramatic display, they are also refining techniques to study the aftermath of such an explosion. One area of focus is the formation of a neutron star or potentially a black hole in the remnants of Betelgeuse. A neutron star is the dense core left behind after a massive star like Betelgeuse undergoes a supernova. These compact objects, which can have a mass greater than that of the Sun packed into a sphere no larger than a city, are an area of intense study in astrophysics. If Betelgeuse forms a neutron star, it will provide an invaluable opportunity to study the behavior of matter under extreme conditions. Neutron stars are also known to produce intense magnetic fields and are sometimes observed as pulsars, emitting regular beams of radiation. The creation of such a stellar remnant could offer critical clues about the fundamental physics of extreme gravity and the behavior of matter at incredibly high densities. If Betelgeuse collapses into a black hole instead, it will be another major breakthrough for scientists studying the formation of these enigmatic objects. Black holes, which are regions in space where gravity is so strong that not even light can escape, have been the subject of fascination and theoretical research for decades. Observing the formation of a black hole from a relatively nearby star like Betelgeuse will help scientists refine their models of black hole creation and better understand the role they play in the cosmos. Furthermore, it could offer new ways to observe the mysterious event horizon, the boundary beyond which not even light can escape, shedding more light on the nature of black holes. Another important consideration is how Betelgeuse's explosion will contribute to our understanding of cosmic rays. These high-energy particles, which are produced in events like supernovae, can travel vast distances across the universe. While some cosmic rays are detected by observatories on Earth, others have been a challenge to study due to their unpredictable nature. When Betelgeuse explodes, its supernova will generate a vast amount of high-energy particles that could give researchers a chance to study cosmic rays in real time. This could enhance our understanding of how cosmic rays interact with the interstellar medium and how they might affect space travel and technological systems on Earth. Additionally, the supernova will serve as a natural laboratory for the study of neutrinos, as mentioned earlier. Neutrinos are notoriously difficult to detect because they rarely interact with matter. However, they carry valuable information about the processes occurring deep inside stars. By measuring the flux and energy of neutrinos from Betelgeuse's explosion, scientists can gain a clearer understanding of the processes occurring during a supernova, including the exact mechanisms behind the star's collapse and the formation of elements like gold and uranium. This could improve our knowledge of nucleosynthesis, the process by which elements are created in stars and distributed across the universe. Beyond its scientific significance, Betelgeuse's supernova will also likely have a profound cultural impact. People around the world will be able to witness a rare and awe-inspiring celestial event, sparking renewed interest in space exploration and the mysteries of the universe. The event will serve as a reminder of the scale and grandeur of the cosmos, inspiring future generations of astronomers, scientists, and explorers to continue searching for answers to the fundamental questions of existence. As Betelgeuse nears the final stages of its life, its impending explosion is expected to deepen our understanding of the universe's fundamental processes. One of the areas where this event could offer new insights is in the study of gravitational waves. These ripples in space-time, predicted by Einstein's theory of general relativity, are generated by massive cosmic events such as the collapse of a star into a black hole. While gravitational waves have been detected from events like colliding black holes, the supernova of Betelgeuse could provide a new opportunity to observe waves produced by the core collapse of a massive star. Detecting these gravitational waves would give scientists valuable data on the structure of spacetime and the nature of the event itself. The supernova could also help refine current models of how elements are distributed throughout the universe. When massive stars like Betelgeuse explode, they scatter elements into space, enriching the interstellar medium with the building blocks necessary for life. This process, known as stellar enrichment, plays a key role in the formation of new stars, planets, and other celestial bodies. By studying the aftermath of Betelgeuse's explosion, astronomers will be able to map the distribution of these elements across the universe and gain a better understanding of the recycling of matter that drives cosmic evolution.